All right, let's get ready to dive into some really cool AI stuff today. We're going to be talking about a new approach to generative models.
Ooh, exciting.
You know, the kind that create images,
Yeah.
write text,
Yeah.
even maybe handle both at the same time.
Multimodal.
Multimodal, exactly.
Yeah.
And we're going to be looking at this paper,
Causal diffusion transformers for generative modeling.
right, Causal Diffusion Transformers for Generative Modeling, which
It's a mouthful.
it is a mouthful.
But it combines two seemingly opposite approaches to AI and gets some really amazing results.
Okay, so we've got this paper. It's shaking things up in AI.
Right.
What are these two AI powerhouses that are getting mashed up?
So the paper focuses on two major paradigms. Autoregressive models, AR models like GPT-3,
Yeah.
which I'm sure you're familiar with, all the...
Yeah, everyone's talking about those.
Exactly. And diffusion models, which are making big waves in image generation.
Okay, so those sound pretty different, right? How do they even work?
Well, the core difference is how they process data. AR models predict things sequentially, one piece at a time.
Okay.
Like, think about predicting the next word in a sentence.
Yeah.
Or composing an entire paragraph word by word.
Oh, okay.
So it's all about building up the output piece by piece.
I see. So it's like constructing a sentence, right? You add one word, then the next word.
Exactly, exactly. Diffusion models, on the other hand,
Right.
work in a totally different way. They start with pure noise, like just random data. Think of a static TV screen.
Yeah.
And then they gradually refine that noise step by step.
Oh, wow.
Until a coherent image or some other output emerges.
So instead of building up, they're kind of like chipping away at this mess, and then the image appears.
You got it. And that's the key difference. AR models are all about sequence and order.
Right.
Diffusion models are all about refining through levels of noise. They're
Nice.
coming at it from opposite ends of the spectrum.
So we have these two very different approaches. How does this paper and this causal fusion thing actually bring them together?
That's where things get really interesting. Causal fusion is like this hybrid genius. It combines both sequential and noise level approaches into one model.
So like getting the best of both worlds, basically.
Yeah.
How does that actually work?
Well, by breaking down the data along both those axes, the model can capture really complex patterns in a much more nuanced way.
So it's kind of like seeing the forest and the trees
Yeah.
at the same time.
Yeah, exactly.
Instead of being limited to just one way of looking at it,
Right, exactly.
it can use both.
Mm.
I'm starting to see why this is getting so much attention.
And the really cool thing is you can actually tweak how much emphasis the model puts on each of those approaches,
Oh, okay.
depending on what you're trying to do.
Right.
So it's not just a one-trick pony. This causal fusion can adapt to different challenges.
That makes it very flexible, huh?
Yeah, absolutely. But speaking of challenges, the researchers were upfront about some of the difficulties they encountered while training causal fusion.
Okay.
It turns out that getting these two approaches to play nicely together,
Right.
it isn't a walk in the park.
I imagine. What kind of challenges are we talking about here?
Well, imagine trying to teach a model to simultaneously juggle different levels of noise
Yeah.
from the diffusion side and the varying amounts of visible context from the autoregressive side.
That sounds pretty complex.
It's a lot for a model to handle, yeah.
So how did they overcome that?
Well, they came up with a really clever solution. They introduced a weighting system during training.
Okay.
So essentially assigning different levels of importance to various stages of the process.
So they're like
Yeah,
guiding it along a little bit.
exactly. This helped the model learn more effectively from both the easy A/B, the difficult examples.
So it's like they gave the model a personal trainer, kind of, to help it prioritize
Exactly.
what to focus on.
Yeah.
Okay, I like that analogy.
And they didn't just stop at the theoretical level. They put causal fusion to the test, focusing specifically on image generation with the ImageNet dataset.
ImageNet, that's that massive data set of images, right,
Huge. Yeah.
that they use to benchmark these models.
Yeah, it's like the proving ground.
Okay, so how did it do?
It smashed it. Specifically, their souped-up version, CausalFusion XL,
Okay.
achieved state-of-the-art performance on ImageNet for image generation. It even surpassed other top models in terms of quality.
Wow. So it's not just a cool idea, it actually
delivers.
delivers. Yeah. That's fantastic.
And they achieved all of this using just a standard diffusion sampling method known as DDPM. No need for any fancy new techniques.
So they're using like the existing tools, but
just good old-fashioned innovation.
yeah, okay, color me impressed.
Mm-hmm.
But We're just getting started. Tell me more about this zero-shot image editing capability that I keep hearing about.
Well, imagine being able to make edits to an image just by describing what you want changed
Hold on.
without having to specifically train the model for that type of edit.
So I could tell it to, I don't know, like, turn that volcano into a car mirror,
You got it.
and it would just do it.
Yeah. And the paper actually shows some pretty wild examples of this.
Really?
They took an image of a volcano and they transformed it into a TV,
Evie.
a sliding door,
Wow.
and yes, even a car mirror.
Yeah. That's amazing. It's like having, I don't know, a magic eraser and Photoshop all rolled into one.
Yeah.
But this causal fusion thing,
Right.
it doesn't stop there, does
It
it?
keeps going.
I keep hearing these whispers about its multimodal capabilities.
Yeah.
What is that all about?
This is where things get even more mind-blowing. Okay. Causal fusion can handle more than just images.
Okay.
It can also process and understand text.
So it's like it understands both images and text.
It does, making it a true multimodal marvel.
That's like the next level of intelligence almost, right? How did they even achieve that?
Essentially, they merged it with a separate text prediction component. Okay.
Similar to a language model, like GPT.
Right.
And get this, they trained it on 2 tasks simultaneously. Text-to-image generation, AD image captioning.
Oh, wow.
So it's learning to both create images from text, ADE, describe images with text.
It's like it's fluent in both languages, almost like the visual language and then written language.
Exactly. And the results are pretty impressive.
Okay.
They actually managed to outperform another multimodal model called transfusion on both of those tasks.
Okay, my mind is officially blown. This causal fusion is sounding more and more like something straight out of science fiction.
I know, but we've only just scratched the surface here.
Oh, no.
We still need to unpack a lot, from the nitty-gritty of its architecture to the implications of this kind of power.
All right, well, I'm definitely on the edge of my seat.
Good.
Let's dive deeper into those technical details and explore the wider impact of this revolutionary AI in part 2.
All right, stay tuned. Things are about to get even more fascinating. I can't wait. Welcome back. Last time we were pretty blown away by Causal Fusion's ability to combine these 2 powerful AI approaches and achieve these incredible results, especially in image generation. But how did they actually build this hybrid model? What's going on under the hood?
Well, they started with a model called DIT, which stands for Diffusion Transformer.
Right.
It's already known for its ability to scale and generate images really efficiently.
So they're basically building on top of an existing foundation.
Exactly. But they had to make some pretty crucial modifications to accommodate the sequential nature of those AR models.
Right, because it's not just about the image itself, but also the order in which the information is processed, right?
Exactly. Remember, CausalFusion has to handle both those noise levels, A and D, that flow of data, like words in a sentence.
So how do they incorporate that sequential aspect into that DIT architecture?
They focused on the attention mechanism, which is really the heart of any transformer model. So in a traditional DIT, the attention mechanism helps the model understand relationships between different parts of the image at various noise levels.
Okay.
But for causal fusion, they had to extend this to also consider the order in which those image tokens are processed.
Oh, I see. So instead of just seeing the pieces of the puzzle, it also has to understand how those pieces fit together in a specific order.
Precisely. They call this innovation generalized causal attention. And it's really key to enabling the model to learn from both the diffusion process and the sequential structure of the data.
That makes sense, but I imagine developing something like generalized causal attention probably came with its own set of hurdles, right? What kind of challenges did they run into?
Yeah, one of the biggest challenges was balancing that training process across all those different noise levels and the amount of context that's available.
Okay.
So in those early stages of diffusion, the image is mostly noise, so the model has very little to actually work with.
It's like trying to read a sentence when you can only see, like, a few letters.
Exactly. And as the diffusion process continues, the image becomes clearer, and the model has more context, making the task progressively easier.
So how did they teach the model to handle these drastically different stages of the process?
They realized that treating all of the training stages equally just wouldn't be effective. So they introduced this clever weighting system, assigning different levels of importance to each stage.
So it's a much more tailored approach to training.
Yeah, you got it. So in those early stages where the image is mostly noise,
Yeah.
they gave those training examples a higher weight, forcing the model to pay more attention to them.
Okay.
And as the image becomes clearer, they gradually decrease the weight,
Ah.
allowing the model to shift its focus to those sequential dependencies between the tokens.
It's almost like a teacher who adjusts the difficulty of the lessons as the student progresses.
Yeah, that's a great way to put it.
Starting with the basics, then moving on to the harder stuff.
Yeah, exactly. This dynamic weighting system, combined with that generalized causal attention, was crucial for them to achieve those really impressive results.
That's amazing how such a targeted approach to training can make such a big difference, huh?
Yeah.
So we talked about the architecture of the training process,
Right.
but what about the results beyond just image generation?
Right. Well, remember, CausalFusion can handle both images and text.
Oh, right. Right.
And this opens up all sorts of possibilities, especially in multimodal applications.
Multimodal, that means combining those different types of data,
Exactly.
like text and images.
Exactly. And CausalFusion shows a lot of promise in this area. They explored two key tasks:
Okay.
text-to-image generation
Okay.
and image captioning.
So in text-image generation, you give the model a prompt, let's say a cat riding a unicorn on a rainbow,
Yeah,
and it would create an image based on that description.
exactly. And in image captioning, you give it an image, and it tries to describe what's happening in that image.
Those are both really complex tasks
Mhm.
requiring a pretty deep understanding of the relationship between
Yeah.
text and visuals.
Oh, absolutely. And to tackle these tasks, they added a separate text prediction component to CausalFusion, almost like integrating a language model similar to GPT.
So they've combined this image-generating power of CausalFusion with the language understanding of a language model.
Yeah.
That's incredible.
Yeah, it's a powerful combination. And then this combined model was trained on both of those tasks simultaneously using a massive data set of images and captions.
And how did it do? Was this fusion of image and language processing successful?
It actually exceeded expectations. It outperformed another model called transfusion on both tasks, showing CausalFusion's, real prowess in that multimodal realm.
Okay, I'm starting to see why this is such a big deal. CausalFusion isn't just good at one thing. It's like,
It's breaking new ground.
yeah, it's breaking new ground in multiple areas of AI.
Exactly, and that's really just the tip of the iceberg. We still need to explore the potential applications, the broader impact that this could have.
Well, I am hooked. Let's move on to part 3 and delve into the real-world implications
Okay.
of CausalFusion and what the future might hold for this game-changing technology.
Let's dive in.
All right, welcome back. So we've gone deep on causal diffusion transformers, the technical details, the architecture, training, seeing how this causal fusion excels in both image generation and those multimodal tasks.
Right.
But let's shift gears a bit now.
Yeah.
Talk about what this means for the real world.
Yeah.
Where could this technology actually make a difference?
Well, I mean, the potential applications are vast.
Yeah.
We're talking, spanning numerous industries. Content creation is like the most obvious one, right?
Yeah.
Imagine graphic designers being able to just describe what they want
Yeah.
and have CausalFusion generate it in seconds.
That would be a game changer for any creative field. No more like painstakingly crafting images
Yeah.
pixel by pixel.
Pixel by pixel, right?
Yeah.
Think about game development. Creating these realistic characters and environments
Yeah.
for video games, for movies.
Yeah. It would be like having a whole team of like digital artists
Yeah.
at your beck and call.
Right at your fingertips.
Yeah. Ready to bring any idea to life.
Exactly. And it's not just about creating new content, right?
Right.
We talked about CausalFusion's zero-shot editing capabilities.
Yeah. Yeah. Those have some pretty crazy implications.
Oh, yeah. I mean, photo editing and restoration could be completely revolutionized.
Yeah.
Imagine removing unwanted objects
Yeah.
from a photo, just like that.
Effortlessly.
Or restoring, damaged family photos, heirlooms.
Yeah. That would be invaluable for so many things.
Oh, yeah.
Like from personal projects to like historical preservation.
Absolutely. And it's not just limited to static images.
Right.
Right. CausalFusion's strength in handling both visual and textual data could lead to some really innovative video editing tools.
So instead of like spending hours editing a video.
Yeah.
You could just tell it to, like, I don't know, remove that person from the background.
Yeah, at a sunset to this scene.
It would just handle it.
Boom, done.
Yeah.
And I think these applications are just scratching the surface.
Yeah.
You know, let's not forget about the potential impact on scientific research.
Oh, yeah. What kind of scientific applications are we talking about?
Well, imagine scientists being able to generate these incredibly realistic simulations of, complex phenomena like climate change patterns, the spread of diseases.
That would really change things.
Huge leap forward in our ability to understand and predict those systems.
What about other fields like engineering?
Oh, absolutely. Causal fusion could be used to design new materials, new structures.
Oh, wow.
Test their properties in a virtual environment before even building them in the real world.
So you can build countless prototypes.
Yeah, exactly.
Virtually saving time, resources.
Exactly. And healthcare, right? I mean,
of course. Yeah.
Think about analyzing medical images.
Yeah.
Assisting doctors in making faster, more accurate diagnoses.
The potential for patient care is
huge. Yeah.
Faster diagnosis, personalized treatment plans,
It's really exciting to think about how this could improve so many aspects of our lives.
Oh, absolutely.
Yeah.
I think we're really on the cusp of something big here.
Yeah.
But, like with any powerful technology, there are downsides.
Yeah.
One that comes to mind is job displacement.
Right. If AI can create content, do things that were previously done by humans, what happens to those people?
Exactly. And I think we need to be really proactive in addressing those challenges and finding ways to adapt and make sure everyone benefits from these advances.
Yeah.
It's a reminder that while we marvel at these advancements, we also need to be mindful of the responsibility that comes with this power.
Absolutely, yeah. The future of AI, it's filled with these possibilities, but it's up to us to shape that future responsibly and make sure it benefits all of humanity.
Well said. Well, I think that's a great point to end on.
Yeah.
We've explored the technical brilliance of causal diffusion transformers, delved into the potential application, and even considered the broader societal impact.
Absolutely.
It's clear that the causal fusion represents a major leap forward for AI.
It's an exciting time.
It is.
And I can't wait to see where it goes from here.
Thanks for joining us on this deep dive.
Thanks for having me.
Until next time, keep those brains buzzing.